This is one of the shortcuts to graphing lines more easily. All right. So 6-1. And I'm going to split this up into 2 lessons. So this is the first part of slope.
2 lessons?
Yes, and there's a reason why not only is slope so important, but I really want you to understand what it is and then how to figure it out another way. We're going to figure it out one way today, a second way tomorrow as well. Yep, Benton?
Is that also called grading?
Sorry?
Is this also called like grading?
Grading, like Grading?
Yeah, like where you're going up.
Mm-hmm. Like a mountain, like the grade of the mountain. Mm-hmm.
Yeah,
That's relates to slope. Mm-hmm. Which let's see if we can get an application here. Who could read on page 325 the construction application that starts with Alan and Mabel Wong? Walker, go ahead.
Alan and Mabel Wong bought a house in San Francisco on which to build a house. The lot is located on a street having an 11% grade.
So that's what you're talking about, Benson, the 11% grade. Uh-huh.
The length of the sidewalk along the lot is 43 feet. City ordinances state that there must be a 5-foot clearance on each side of the house to the property line. The house they would like to build is 32 feet wide. Will they be able to build their house on the lot they bought?
Okay, so it's interesting with San Francisco because I lived right across the bridge to San Francisco. And what was interesting is when I was first learning how to drive, when you go up some of these streets in San Francisco, you're having to push the car a little bit. And then when you stop and you're stopped like this, and if you let go of that brake, what's going to happen? You're not going to go forward. You're going to go backwards. So those are really scary times. And people lived on streets where you're like looking at their house and they're like, the street is slanted, but the houses are upright, obviously. Like Full House, that house is by a park we used to go to. And it's funny because my wife loved Full House growing up, and we had to go to that park. And I think we saw the house that they show on there. They all look the same, by the way. But we think we saw the house, and now, that was something for her because she liked that show so much. No, I think it's actually occupied. Like, people live there, so. Dun, dun, dun. Yeah, that would be interesting. But anyway, these homes are on a slant, and you can see that they're upright. And this is saying they need a 5-foot clearance on both sides. But it's not just as simple, you just measure with a ruler, or some kind of tape measure, 5 feet, we're done. Because of the slant, you have to measure it a different way. Now, unfortunately, since we didn't go over trig, we wouldn't be able to find that out with the tools we have now, but we will be able to if we learn that trig later on this year. It is coming. Okay, do you guys see those? You see those ladders there underneath that next diagram there? Okay, do you see it's leaning against like a building, okay? So I want you to look at the far left one. Would you say that climbing up that ladder is climbing up a steep ladder? Is it pretty steep? Okay, almost completely upright. And then as you move further to the right, what's happening to the ladder's steepness? Decreasing, right? It went from like going kind of almost like you're going upright to kind of like, oh, wow, this is not too bad. And then you have the least steep ladder. Okay, the idea of steepness is critical to slope. So what I'm going to do here is I'm going to define slope in many different ways, and then I'm going to stop on one that is the most important way for our purposes. So slope simply means steepness of a line. How steep is a line on a coordinate plane? That's what you're dealing with slope. So the steepness of a line. Another way to put it, and I'm just like, last year I didn't go through the last lesson that we did in chapter 5 with other students with the equation from patterns and equations. But now that we did go through it, you're going to see that there's a direct correlation to slope. Okay, ready? Another way is to say change in y over the change in x. So that should at least maybe ring a little bit of what you've done in the past. Does anyone remember what this kind of, maybe, sort of looks like? It's a ratio.
Y sub 1 or 2.
Oh, I remember.
Oh, are you thinking y sub 2?
Minus y sub 1, or x sub 1 over x sub 2 minus y sub.
Okay, yeah, did we do that this year or was it last year?
Yeah, we did it both years.
Okay, so good memory on that. Yeah, that's part of it. And then what did you do just very recently with this? Kinda, sorta, maybe. Okay, those are ratios too, but even more recently, I'm talking like days ago. The patterns. Remember what the top part of the ratio was? The range. Do you guys remember range differences?
Yeah,
Domain differences?
Yeah.
Okay, ready? What's range referring to? What's domain? Okay. So watch this. I'm gonna tie that in tomorrow on how that relates to what we did last chapter. But anyway, this is what you need to know. That slope is I'm trying to say this the right way, is defined or it is stated with the letter M. So when you see M, what does this mean? Slope. Okay, when you see M, it means slope. Especially in geometry or this coordinate plane stuff. Rise over run. How many of you have ever heard that? Rise over run. Okay, maybe you haven't heard it. Some of you have. Good. This is what I want you to know. Rise over run. Okay, and we're going to look at this a lot today. So all three of these relate to one another, okay? And then, actually, you know what? I wasn't going to write this, but I am going to write it now. This is the one you need to know. Like, please don't forget it. But there's another way, and it's the range differences over the domain differences. And you know what? I need to change something real quickly on this, because this is going to give us some hope. Okay, so I wrote that out, and the thing I'm going to change is this. The big change. Difference.
Oh my word.
Okay, the change was from plural to singular. Do you guys remember those tables and finding out the range differences and the domain differences? Do you guys remember that?
Yeah.
You just did this yesterday, I hope. Well, yeah, okay. And 2 days ago, you probably did it. You did it many days. You only had to find one of those differences, and you would have been done. So remember that table? I'm going to draw it. You don't have to draw this out. Remember that table with the X and Y? You only had to do it once. That's it. Why can I say that you only had to do it once? Do you guys know why? Taylor. It was a pattern. Didn't it repeat? But Mr. A, didn't some of them have different numbers?
Well, they would simplify.
Yeah, let's say I had here, some of you had like 4 and 1. I actually hasn't anyone, I'm not going to refer to anything. Okay, and then I had 12 and 3. So you're like, Mr. A, they're different, but look at this. What's this ratio? 4 over 1. What's this ratio? It's still 4 over 1. So I really only had to do it once. I only had to do it once to figure out that ratio. And you know what that ratio was?
Yes. 4.
Sorry, on that one, yes. The ratio was really called it is the slope. You were finding the slope the whole time. I'm starting to get nervous here as I grade them soon. I'll grade them soon. Okay.
Oh, from the I knew.
Uh-oh. Okay, let's go ahead and draw a coordinate plane. And I want it to look a little bit more like this. So I want the first quadrant to be the biggest quadrant. Yeah, because I'm not going to use this part right now. I'm going to use that first quadrant to point out the slope. I want you to put a point on the origin. So we have a point on the origin, and we'll go by ones. 1, 2, 3. 6 is enough on the X. And 5 is enough on the Y. So it should look something like this. Please sketch this out, because I'm going to do several of these, and I want you to really get what am I talking about and how do I find that slope. All right. So there's a point on the origin, and I want you to put another point at 5, 4. 5, comma 4. So please put one other point at 5, comma 4. 1, 2. Okay, so put that second point. And then, yeah.
So mine is like not as this. It's like this. Like
Oh, the steepness?
Yeah.
Okay, let's connect the line and I'll describe what may have happened. Whoa.
Oh my word, you only need 2
Oh,
points.
I love lines.
Yeah, I know. There are some. I mean, they're looking at it and it's cool. Like I like it. Some of you are really like particular. I need a straight line. That's good. But Mr. A, he has to work on his straightness a little bit more. Okay, so everyone have this line right here. Everyone have this line right here.
Yes, yes, yes.
Okay. So what we're going to do in this lesson is we're just going to look at the steepness. Okay. So looking at this here, how do you find out that steepness? There are 2 ways. Actually, 3 ways. We're going to look at the easiest way. Is to simply look from one point to the other. Okay? Now, I'm going to mark this up go with a different color here. Okay, what I want to do is I want to measure the change in y over the change in x. So what is a y referring to? What part of the graph is y, or what direction is y, possibly?
Up and down.
Up and down. Okay, always think y is vertical, up and down. And x is? Run, horizontal. All right, ready? So if I go from here to here, how far do I go up? 1, 2, 3, 4. You guys okay with that? I went up 4. And going up is a positive thing, going up. If you went down, it's negative, but in this case, I go up. And then how far am I going to go to the right? So here, 1, 2, 3, 4, 5. Sorry.
That was beautiful.
Yeah, I kind of messed it up. But anyway, 5. Okay. So what I want to figure out is what is the slope. Good. When I put M, you're thinking slope. Yeah. What's the rise? What was the rise here?
Change in y.
Yep, good. Which was 4. And what was the run?
5.
So the slope was 4/5. That's the slope. And that actually, we're not looking at this today, but that would be half of your equation already. You already have half. And to find the other one is actually super easy, even easier than that. Yep.
So yeah, I got that. Is it okay if it looks more spread out than that? Like
Yeah,
this?
sorry, I forgot to bring that up, Walker. Okay, so some of you are looking at this and saying, well, Mr. E, mine is kind of like, it's a little bit less slanted or a little bit more. What could have caused that maybe? You're not wrong.
The spacing between the
Yeah, if you space these out more, like these tick marks more, it's going to be stretched out
Okay.
either way. Oh, yeah. But I can see from your tick marks, if I look at your paper, that this is 4-5, or 4, 5, and that's 0, 0, and that is the correct slope. So they might not look exactly the same, but they should be rise 4, run 5. Everyone okay with that?
Yeah.
Okay, that's your slope. It's 4/5. And that is also the range difference over the domain difference. That's it. That's what it is. Okay, let's keep going here. Let's see. Okay, I got to keep going. Okay, let's look at example number 1A on the next page. So this is what you're going to be doing. And I was debating, do I have to draw all of these problems out? And I do, because I want you to keep these as notes. So here, I want you to draw another one that has a bigger first quadrant. And just go 5 and 5. 5 and 5 out. And they give you this on your example, but I want you to draw it out so you can have it for your notes. You can refer to it. Okay, they have, if you're looking at 1A, it says determine the slope of each line. And so looking at A, what are the 2 points that they have on their line? What are the 2 points? Can anyone give me those coordinates? The 2 points. Vivian, can you give me 1 point on A?
2, 1.
Okay, 2, 1 should have a point. 2, 1. So put your point there. And then, Riley, can you give me another, or the other point, I should say. So she gave me 2, 1, and I need another one.
Is it 4, 4?
Yep, looks like 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, and then go ahead and connect those with a line. Man, I did this like, even on my paper, I just missed the dots. I'm getting older. And you shouldn't be afraid of me in dodgeball because I'm like, I'll aim for you, but that doesn't mean I'll hit you.
Well, I mean, with the person attempting to dodge it, and then you actually miss it.
I actually hit him on accident.
Yeah.
Oh, thank you, Eli. That gives me some hope. Okay. When you're trying to determine the slope of a line, you have to have 2 points. So you see my 2 points here? Okay, now, I'm going to work it 2 ways to show you that you can do it either way and still get the correct slope if you understand positives and negatives, okay? Please listen up. All right, I want to go from this point to this point, okay? So how far did I go up?
1, 2, 3.
I went 3 up, right? That's my rise. And what is my run?
2.
2. I went to the right. It's positive 2. All right? So what is my slope?
M equals 3 over 2.
3 over 2. Yep. And do you notice that I'm not changing this into a mixed number? I keep it as improper fraction. That's the best way to use a slope. Okay? So everyone see how I got that? Well, Mr. A, you know what? I want to see if you can do this differently. You can. All right, you know how I went from this point to this point? I can do it the other way as well. We'll go with this color. All right, from this point to this point. All right, how far did I go down? 1, 2, 3. Now I went down, which means it's negative 3. Uh-oh, this is already looking kind of rough. And then I have to go 1, 2 to the left, which is negative 2, right? Do you guys see that? Okay, but Mr. A, that means your slope is negative 3 over negative 2. And what is negative 3 over negative 2?
3 over 2.
It's positive 3 over 2. So this is the correct answer, and you get it either way. That's okay. I know it's exciting. I like this stuff. Are there any questions on how to find the slope so far? So far. Okay. You need 2 points. You need to find the rise over the run. And you need to keep the signs straight because they will affect this slope. You can have positives and negatives. All right, let's look at B then. B is going to give me, I'm going to draw another coordinate plane. It's going to be a larger fourth quadrant. Fourth quadrant. So if you can give me the fourth quadrant, I'm good. And we'll go 5 out each way. And can somebody give me what their 2 points are on that graph? So Lizzie, can you give me 1 point on B, or for line B on example 1?
1, -1.
1, -1. So 1, -1 is right here. Do you guys see how this is first quadrant, second quadrant, third quadrant, and then a big fourth quadrant? So that's what I'm doing there. I need the second point there. James, can you give me the second point on B?
4 negative.
Good. 4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And then go ahead and connect them with a line. Wow. Yes, got it.
Is it okay to make our graphs like that, like one big, one big?
Yeah, you could. Thankfully, in this case, it's not going to affect it too much. Later on, it will, and that's when I'll use graph paper up here. Because, yeah, you got to be very specific. Yep.
What if the thing we like shade under the
Yes, that's when you're graphing. Yes, we're going to get into this. Not this chapter. No, we're going to get that. That's later on. But that's inequalities. Graphing inequalities. Actually, you know what? Now that I think it might be at the end of this chapter. Okay, looking at this right here, do you guys want to work from this point to this point? Is that okay? We're just going to work left to right. Okay, so here with the different color, how much did I change in my verticality? What did I change in the verticality? 1, 2, 3, 4. -4 because I went down 4, right? I went down 4. And then how many did I go and which direction did I go?
3 to the right.
I went 1, 2, 3 to the right, which is +3. Okay, so what is going to be my slope on this problem? What is the slope?
-4/3.
Okay, you can put it in many ways. Here are the 3 ways you can put it. Ready? It's going to be -4/3, which is exactly what I have there. You can also have 4 over -3, or you can have the last one is -4/3. Are they different, same, or what? What do you have? It's all the same. Now, how in the world could anyone get that? How in the world would anyone get this? Like that? I get this and that because they make sense, but no. You can't have a -3. Not on this one. Eli?
They believe that right lives matter too.
Yeah, right. Oh, wow. So they went up 4 and to the left 3, +4, -3. And then this one is representative of both. All right, anyway, you got that in there. I think really the best one to put is the last one, -4/3, because it's regardless of whether you started from left or right. They're both going to be the same. Yeah, I'm not going to be too picky, but this is the best way to do it. Alert, the best way to do it is right here.
Why is that? Because the -3 and -4 tell you how much.
Yes, but what's also cool is when you're going to be given the slope later on, they're just going to say the slope is -4/3, awesome. And then from that, you can graph either a point to the right or to the left based on this. So we'll get to why, but that's probably your best way
So
for now.
with that, it could be it could be a lot of points, couldn't it? Like you can have many answers, right? Because it could be, yeah.
Okay,
It's not a specific point for if you're given the -4/3 slope, well, you don't really have a specific point to start at, or do you?
You will, and that's the cool about slope-intercept form. You need your slope and you need an intercept, and then you can graph it, and we'll get to that. Now you actually, Walker, you gave me 2 things here that I want to work with. One later on, what we're just directly talking about, and then you said you can get different answers. In fact, you can. Okay, look at this right here, guys. And I'll use the same marker not to confuse you. Okay, sometimes you'll get easy simplified fraction like 4/3, but sometimes you can get this sorry, I thought it was the same. -8/6. And you're like, wait, okay, yeah, what would this simplify to? So are these the same? Yes. Okay, they are the same. I want it in the simplified form. That's the best way to use it, again, for graphing later on. We'll see that more. But anyway, let's go on to C. Oh, C is different. C is going to be, what kind of line is that, by the way? What do you call that? C. Horizontal. All right. And really all you need is a few points on the Y, and then it's going to be this horizontal. And then actually, no, you will need a couple to compare on the X. So nothing too big. Okay, what are the 2 points they have on that graph labeled? So what are the 2 points? Kendall, can you give me one of them?
1, 2.
Okay, 1, 2 is right here. And somebody give me the second point. Harper? Mm-hmm. So you have to have 2 points to get that slope from that line. And so I have my 2 points. And this is where it can get a little bit tricky, but you just go through the same process. How much did I change vertically? None. I didn't change at all. You know how do you know how you represent no change with the number? 0. All right. So my slope right now is 0 over. And then what did I change And I'll go from here to here. So 2 to the right. So I went positive 2. You guys okay with that? It's positive 2. Mr. A, what if you went from right to left? It would be negative 2. This is the cool part. You can get either this or that. But what do they both equal? 0. The slope of this line is 0. That's the slope of the line. In fact, can I ask you this question? If you had a ladder in that orientation, how steep is it? It's not steep at all. It's flat. Yeah, it's just lying on the ground. Flat. Not steep at all. Has no steepness. Does that make sense? No steepness? 0. It's a horizontal line. And then if you're looking at B, you're thinking, uh-oh, this one's what kind of line? Vertical line. So it's going up and down. And this one, actually, I've been researching this more and more, but I'll tell you what I know so far. I'm just going to go and draw, again, a larger fourth quadrant. All right, give me a point, Benson. 2, -1. Josh, give me the other point there.
2, -4.
2, -4. 1, 2, 3. Okay, so I have my line. Oh, so close. All right, so we're going to go through the same process. Beth, from this point to this point, how much do I change vertically? Vertically. 1, 2, 3. And you just count from here to here. How far did I go up? Positive 3. How far did I go left or right? I didn't move at all, right? So look at my slope right now. M equals, does anyone know how to write it? 3 over 0. 3 over 0. Okay, and this is where it gets tough. The answer, yeah, you're going to get an error in your calculator, and the answer is undefined. And kind of think of it, let me just go with the practicality. Think of a ladder that was standing straight up. How would you describe that steepness? I would say like very steep. Like it is the most steep it can be. It's not actually steep. It's just a straight line up and down. Like you're climbing up a steep mountain that has some kind of slope to it, either coming out at you or coming away from you.
How come when you're climbing like a
Ladder?
Yeah, like a rock wall, what did you call it? Kind of steep.
Yeah, you would, and I guess that's well. Yeah, I guess you would call it steep, but I guess that's a poor illustration. But how would you describe the steepness of it? I guess is straight. Yeah, you would say straight. It's not positive. It's not negative, which we'll see. Yep.
So I have a couple questions. So on number C, or letter C.
That's okay.
So
He's thinking algebra, by the way, because letters represent numbers. Go ahead.
True.
Go ahead.
So why isn't it like -2? Because what if you started there and went?
Sorry, C?
Yeah.
So you see how I got these two? But 0 divided by 2 is 0. Like 0 out of 2 parts. Or 0 out of -2 parts. It's a 0. Which is nice.
I'm still confused with range difference and domain difference.
I see. You know what I'm going to do? I'm going to show you when we're working on homework. I'll draw you a little quick table and show you how you would get that. Because you would get, how about this? You would get this little table here, your x and y. You only have 2 points. The point here is -1, 2. So -1, 2. And this point is 1, 2, 1, 2. So what would be your range difference? What would be your domain difference? 2. So 0 over 2. So that's your table work. And notice how many points did I need to use? Instead of the 5 you used to do, you only need.
So you can do that if you need to.
Yes. Yeah, you can if you want to see it that way. That's fine. Okay. here are the last remarks of this lesson here. There are 4 things I want you to get. And it's related to each one of the problems in example 1. Okay, example 1, if you look back at it, please. Example 1A, I should say. Example 1A, the sign of the slope is what? What's the sign in front? It's positive. Okay? Look at the line compared to the slope. Positive means this. Please think of this, and I'll drill it more as we keep going. When you're looking at a book, you read it left to right. You know, when we read English, our language is left to right. Their languages are opposite, but we're left to right. Okay. As you're going left to right, your marker is going up, which is a positive direction. Does that make sense? Positive slope, you're going up left to right. Look at B. Do you guys notice the difference? From left to right, where's this marker going? Down, which means I have a negative slope.
What if you're doing taxes? No, good.
Oh, yeah, no, and these things aren't saying like that's bad or good. It's saying you're going upward or downward. So, yeah, not bad or good. It depends on the application. Like Mr. A, as time goes on, his weight goes down. It's a good thing. I like the negative slope. Sorry? Yes. With C, if you have a horizontal line, if you have any horizontal line, slope is automatically. Horizontal line, slope of 0, automatically. And if you have a vertical line, it's undefined. And guys, it's undefined for a reason. I can't define it. Like I'm trying to, how do I describe it? We're starting to get into calculus stuff and like number theory. Like what do numbers even mean? That's above my head and it's above our heads for Algebra 1. Okay. Yeah, it's error. Error in my head. And for those calculators that cost so much. Okay. I want you guys to do problems 15 to 29.
For homework?
For homework.
Okay, you gotta do them.
Right in your bike to the left, and you go in that.
When you graph paper,
Oh, yeah. So some people would do that, but always read it left to right. So when you do this, always read left to right, and then you'll always have the sign. No, because they have all their graphs. Hold on. I think I may have had.
Don't ever fail word again.
wait, what was the number?
Let me pause this real quick.